knowledge is power. The more knowledge you have, the more you can say, do I know on any given day what the Russians would do as far as indications of hostility? There was an absolute certainty. All the Russians were 10 feet tall. They were all evil. They ate little children. They were just about the killers of the Western world.
In the early 1950s, as Cold War paranoia swept through America, the CIA formed a special technical division to steal secrets directly from the mouths of the communists. Working with cumbersome technology, which was hard and exhausting to hide, it was their job to plant listening devices in Soviet bloc installations the world over. Glenn Whidden was one of the first to become an eavesdropper for the CIA.
The people who were actually on the road doing the job probably numbered 24, and they were busy a lot of the time. We were required to travel pretty much throughout the world to install eavesdropping devices, and once in the target, it was a tough job because we had things like that big doorknob microphone that had to be concealed, and that type of thing requires a pretty good sized hole. It will only send a signal over a wire line for a limited distance.
The thick 1950s cable needed to be painstakingly hidden in walls or under floors and run out of the building to a listening post where the conversations could be recorded. Embassies were often the target, and so an ideal situation was to discover when the Soviets were planning to move to a new building.
The agency's job was to find when those moves were going to take place and then to give us enough chance to get there before occupancy to make the installation. I much preferred to work alone because if I heard a strange sound, I know it wasn't me and it wasn't anybody with me. I used to frequently made surreptitious entries. I do it in a business suit because if you were observed in the vicinity of the target, you might not arouse as much suspicion as you would if you had all black with a ski mask. I have left targets soaking wet from perspiration and literally having lost perhaps 10 pounds of weight.
Often it was impossible for intelligence agencies to gain access to the buildings or rooms they wanted to bug, so special tools were developed to allow them to plant bugs through the walls of an adjacent building. 40 years ago, Lee Tracy installed bugs for Britain's Foreign Intelligence Service.
What I'm holding here is an old probe mic of the 1950s, 1960s, and this has a sharp point on the end, and this was used to try and get through the final bit of plaster if you didn't happen to have the right gear and you'd try and force it through. But what you really needed was a silent drill, because you would not use this part anymore. What you would then use is just this. And the technique behind it is to drill a hole big enough to take this and get this right through the wall up to the plaster on the other side. It's no good misjudging it and just going crashing through. Just make a mistake and hit that plaster too hard and you're finished.
Silent drills are classified as secret in Britain. This modern kit, obtained in France, contains everything the eavesdropper needs to quietly cut holes in walls.
You've got a drill here which is silently operating inside this case, and it stays in the case while it operates. The flexible control comes out into a unit here which takes water in and sucks all the muck out and keeps the drill silent. It might take you, say, only 10, 15, 20 minutes to get through the main brick, and it might take you another 3 hours just to get that final little bit till you hit the plaster. Right, now that we have the large hole, which will take the microphone capsule and the electronics, we need a tiny 1 millimeter hole through the plaster on the other side, and we use this tiny, very, very thin, careful drill to do that. And I gently work it until it goes through the plaster, and all I want on the other side is just a 1 millimeter hole, and there it goes. And that's done. And I now push that in there till I reach the other side, and there we go.
In the 1940s, the problem facing intelligence agencies was how to bug rooms they couldn't get anywhere near, like an ambassador's office. But in 1948, the Russians solved the problem and created a revolutionary bug which they concealed in a carving of the Great Seal of America.
They presented the American side with this eagle, and, which was put on the wall of the office of the American ambassador.
What the American ambassador didn't realize was that hidden behind the eagle's beak was a transmitting bug which had no batteries, no microphone, and needed no wires. Called a passive cavity resonator, it was activated remotely by a powerful radio beam, which it reflected back out of the building, carrying with it the ambassador's conversations.
The device, as I understand it, was in place for 3 or 4 years before it was discovered. It also caused enough of a flurry over here so that we spent, I would say, literally millions of dollars to try to develop detection equipment that could be used to detect that sort of thing if it appeared or was in use elsewhere. It turned out that, in our experience at least, it wasn't used anywhere else.
But the Americans weren't the only target of the KGB.
It was possible for us to install one of such devices in one of the offices of the British Embassy.
Today, retired KGB technicians are only too pleased to show off later versions of their astonishing passive cavity resonator. The British and Americans copied the device, but by the 1960s, the growing number of television sets helped highlight the bug's fundamental weakness. The radio beam it requires is so powerful, it can sometimes interfere with other broadcast signals, making the bug susceptible to detection. Avoiding detection is the hardest lesson to learn for the eavesdropper.
What I teach is to use what microphones already exist in the room. By far the most dangerous microphone in any room is the ordinary loudspeaker. They can be found in TV sets, radios, telephone earpieces, telephone mouthpieces, all of which can transmit a signal through a pair of wires to a listening post. I'm going to take this ordinary loudspeaker and simply hook a pair of wires to it. It's plugged into a tape recorder, and I'm going to record a brief segment using this as the microphone itself. It doesn't matter what the physical size is, they all work the same way. Sound goes in, electricity comes out. I'll stop it, rewind, and play it. It doesn't matter what the physical size is, they all work the same way. Sound goes in, electricity comes out.
Once an eavesdropper has adapted an existing speaker into a microphone, to avoid detection further, they will try to use the building's existing cables to get the signals out. Bugging a telephone line has always been a favorite of the eavesdropper. Known as the wiretap, if it's done properly, it is virtually impossible to detect.
Let's just hit the wiretap briefly. See, this is what used to be used, just an ordinary relay. The main drawback with this thing was this is what created the infamous click on the phone line when you connected it to the phone line. So the way they solved that problem was before they connected it to the phone line, they would wet their finger, place it on the phone line, and then slide the clip down the wet finger until it contacted the phone line, and that eliminated the click.
In the early 1950s, the CIA and SIS, Britain's secret intelligence service, more commonly known as MI6, had started one of the most ambitious telephone tapping operations of the Cold War. In Berlin, then a divided city controlled by the Allies, they discovered the main telephone lines, connecting the KGB's Berlin headquarters with Moscow, lay just 400 yards away from the border of the American sector. The only way to reach the lines was to dig a tunnel.
The total length of the tunnel from the warehouse to the actual site of the East German cables that were tapped was about 1,500 feet, actually 1,476 feet to be precise. Then the horizontal tunnel began, and it continued on until just when it got to the point where we wanted to tap the cables. And then technicians from the GPO in the UK came and actually carried out the tap, which was a very dicey business, very difficult. You needed highly skilled technicians. This could never have been done without British expertise in this area.
Hundreds of individual lines were tapped, and in May 1955, Soviet secrets began to flow through the Berlin Tunnel.
As an intelligence officer, what got me was the enormous amount of information on Soviet units, their personnel, their equipment. All of that was absolutely fantastically valuable.
But more than a year before tunneling had even begun, the KGB sent a young agent, Sergei Kondrashev, to London to meet their most valuable spy, a middle-ranking SIS officer called George Blake.
In January '54, he passed me a very important information, and that was the minutes of an Anglo-American top-secret conference between CIA and SIS on laying plans for the building of a Berlin tunnel.
In a calculated sacrifice, the KGB in Moscow decided to let the tunnel go ahead. They knew George Blake would be the prime suspect if they tried to halt the tunnel's construction. Believing the British secrets he would betray were more valuable than their own, even the KGB in Berlin were not told their telephones were to be tapped.
They couldn't take a chance of not allowing it to continue for at least a while until, quote, they accidentally ran across the trap door leading to the tunnel.
Unfortunately, I must admit that the American and British side have got enormous volume of a very vital information.
The tunnel operated for a year and a day before the lines finally fell silent.
And so it was decided, after consultation with George Blake, we'll open it and use it in diplomatic and propaganda purpose. Correspondents from all over the world were invited to see the tunnel, and the films were issued about this building, etc. So that was the story of the tunnel.
As the tunnel closed down, a technological revolution was about to open up a whole new range of possibilities for the eavesdropper. In the early 1960s, the introduction of a tiny electrical component, the transistor, revolutionized the world of electronics. As the world tuned into their new portable radios, the CIA were exploring new ways of tuning into the Soviets.
We were dealing with a salesperson who represented a hearing aid company. And hearing aids were coming down, down, down in size because of the advent of transistors and small batteries and small microphones. So I said to him, could you put a little amplifier right on the back of a microphone? And he came back a few weeks later and said, yeah, the factory did it, here it is.
For the first time, the transistor made it possible for the CIA to produce tiny battery-powered transmitting bugs. Free from having to hide wire lines, suddenly, for the eavesdroppers, a whole new range of targets came within earshot.
I remember one situation where it was an official target. It was, as a matter of fact, pardon the expression, an ambassador's office. And the cleaning boy was a local national who wasn't averse to taking a little bit of money on the side. I gave him a camera and told him exactly where to stand in the room and take some pictures. He did. I printed them up and saw there's a piece of furniture here that would be ideal. It's a coffee table. There's a sofa nearby, and the ambassador's desk was 15 feet away, which is very tolerable in audio surveillance.
The next day, Glenn sent the cleaning boy back again.
Turn the table over, measure this dimension and this dimension accurately, and give me a sliver of wood from the underside. He did, and 2 days later I gave him a wood block which contained an eavesdropping transmitter with a remote control switch and battery pack. And he put it in. About 2 days later, I drove by the target in my car. I had the audio output from the receiver going through the car loudspeaker so that I wouldn't go by wearing headphones and give the whole thing away. And I pushed the button and boom, on came the signal, and it was very quiet. You could hear bird sounds and a little bit of typing from down the hall, and it was the sort of thing that would bring tears to the eyes of a good eavesdropper.
Bugs could now be hidden in just about anything. Books, ornaments, cuddly toys. The KGB even hid one in the shoes of an American diplomat. And British intelligence created a listening pen.
This was created for a specific purpose. And the specific purpose was to visit somebody and leave the pen and come back for it. Because what you were after was what was said in the few minutes, perhaps only a minute, after you'd left. So the pen needs only to last 2 to 3 minutes. It actually lasted about 2 to 3 hours. Inside there is the transmitting section. How much room have you got for batteries? And what size batteries are they? Tiny little things. They can't possibly last any time. So it's utterly pointless to use a device like this as a general bugging device.
Another type of specialist bug, known as the drop device, is designed to be hidden in a matter of seconds. But given time and access to the room, the hiding places for transmitting bugs are unlimited.
One of the best places is a large cavity in cavity doors, such as we have here, because you can get a whole string of batteries in with the bug, which will give it a chance to last for months, maybe even a year. Here we have a ready prepared string of batteries with the transmitter section, which also has a radio control section for remote control switching, and down into the microphone, which is concealed in the cork and actually works between the top of the door jamb and the door.
The trick is to drill through the top of the door to reach the hollow part inside.
Right, we're through to the cavity, and out she comes.
The string of batteries are then put into a lady's stocking, which, once fed into the door, is filled with polystyrene balls to ensure it doesn't rattle as the door opens and closes.
We've now got to push this down inside, get our cork in position, and there we go. Our final little touch is to add some prepared dust, which we do by usually a woman's brush there, and just brush that on the top, so that should somebody come along and run their finger along the top here, they'll find dust and think that's never been disturbed. They're usually too lazy to get up and take a proper look, so we have a nicely fitted transmitter in there which will last a year.
Whilst MI6 were busy eavesdropping through hotel doors, the American military were attempting to listen to a much bigger target, an entire army hidden in the jungles of Southeast Asia.
Igloo White was the code name for a program designed to monitor infiltration down the Ho Chi Minh Trail during the period of U.S. involvement in Vietnam.
There were dozens of different sensors developed. The size of a small tree, the ADSID was the biggest of them all.
This thing is thrown out of an airplane at 251 pounds coming out of the sky. It pretty much buries itself in the ground. So about the only thing sticking up is from about my hand up. So you'd be going down the trail, all you'd see is this little plant-like thing sort of buried in the woods.
Once triggered by a specific sound, like a Viet Cong convoy setting off a mine, the sensor would send a signal to a nearby aircraft, which in turn relayed it to a ground station. In theory, the trucks could then be located.
I'm told that one of the problems was that this antenna, which is a very costly item to manufacture, is a copy of a plant that didn't exist in Vietnam. Consequently, the North Vietnamese coming down the trail would see this strange-looking plant that didn't grow in Vietnam and say, must be another one of those American sensors. They dig it up and there goes the sensor. We spent about $92 million on this program, and it turned out that it didn't stop the infiltration.
Plastic plants in the jungle may be easy to spot, but a tiny transmitter planted in a room is much, much harder to find. That's the job of a specialist bug hunter, known in the trade as a sweeper. In the early 1960s, the best way to locate a transmitting bug was to find its signal as it broadcast the stolen conversation over the airwaves.
Think of that in relation to your radio and perhaps your car radio, and how long it takes you to just keep on turning and turning and turning to look for a station. What you're covering with your radio is a fraction of the spectrum. In fact, it's probably something in the region of about that much. But a bug could cover that much. So now you've got to tune from there to there, looking for the bug. And that could take you days, and that's the problem.
In 1962, Lee Tracy invented the scanlock, and suddenly bug hunting got a lot easier.
This is scanning all of the time, a massive range, way into the gigahertz range. And it's doing so in less than a second for the whole scan. Now, I will switch this bug on, and if you watch these lights here, as soon as the red lights appear, it means that this has detected this bug and locked onto it. So I'll switch it on now. There, instantly, it's locked to it. And over the sound, your sound engineer will actually be picking up my voice through this bug.
But in order to defeat the sweepers and their scanners, the eavesdroppers have developed innumerable ways to hide or disguise their transmissions. And with the development of remote control devices, if the eavesdropper suspected someone was looking for their transmission, then they could simply switch it off. But one man invented a bug hunting gadget that will find them regardless of whether they are working or not.
That is the first of the brooms, the nonlinear junction detectors. That's the very first of them, which I made 23 or 4 years ago. And I did some very good detection with it.
In the 1970s, the production model of Charles Boville's machine was a closely guarded secret.
Here's another bug.
It works like a highly specialized metal detector, which will only find electronic components.
The nonlinear junction is to detect anything with a transistor in it by sending out a radiation which disturbs the transistor, which immediately transmits. It's a brilliant concept when you think of that. Everything has to use a transistor now for size and power consumption and so on. And everything that has a transistor in it will be detectable on that device.
New fiber optic devices will defeat Charles Boville's machine. And in today's high-tech world, the days of the men in sheds are numbered. But whatever technology eavesdroppers use, in espionage, everyone expects the walls to have ears.
We had a young lady who was, I won't give her name, but cute as a bug's ear. We'd pick her up on telephone taps, and every so often she'd talk to her boyfriend somewhere, and she'd say, "Careful, the worms are listening," ha ha ha, and then keep right on going. But she was always thinking of us, and I just couldn't believe she was a communist.